Okay, so let's address another case, always with the mix and elbow. So now let's move to V2. So in V2 here we have also different geometries, different variations, and so on. Here, when you open the run mesh parallel, you have here now different cases and short explanation. Now, so pretty much like in previous now assemble. Here we have the mesh with the fillet. By the way, recall that on shape we added a fillet, and this I leave it to you as an exercise, but it's when you add the fillet, it will change a lot, no? Uh, how the mesh is generating in particular, it will improve a lot the boundary layer meshing. Okay, so try to do it and you will realize immediately. So it will be up to you if you can live with that feeling or no. But from this case, the one I want to run is the one with the single surface because I want to show you how we can split that surface. So we saw how to do that at the level of the surface, the STL or OBJ or whatever you are using. Okay, using Mesh Mixer or Surface AutoPatch. You can also use Blender, whatever. But what if we have the mesh and I want to do that separation? How we can do it? So that is what I'm going to show you. And of all these cases, the one that we need to run is case 2. So see that is geometry was exported from onshape as a single solid, no regions, normals are okay. So let me use this one. And let's run this case or run mesh parallel. Okay, so it will do the mesh. We know that everything is predefined already. So if you want, you can open snappyHexMesh. Here is version 2. Yeah. So here you have the dictionary, what you're reading. So this one is also interesting because I'm reading as well many surfaces. So if you go here, you can see that you are accessing extra surfaces. You can apply region refinement and so on. So here I make it a little bit more complex. V1 was very clean here, reading many surfaces and so on. So here refining level, by the way, 4.4. So it will take some time refarming regions and see how we access those regions. Here we have the pipe small enclosed, so you can open now all the surfaces and you can see what we have, so you can get an idea of what we're doing. So yeah, basically what after having the mesh, you will realize that you have a single patch. So how do I set boundary conditions in a single patch? I have my mesh. I don't know how to separate my STL or my geometry. How do I do it at the mesh level? So let's wait for our mesh and we show you that. And actually we have it here. So very good quality. As I say, we have a single patch, so that will be a big problem. Even if your mesh is a perfect mesh, perfect quality, single patch, it is a big problem. Okay, we cannot set boundary conditions. A few orthogonal cells, but that's it. Okay, nothing, nothing major. So this point, how do we create that? And let me see. Okay, so let me do reconstruct par mesh, reconstruct par. I don't recall is if the tool that we're going to use works in parallel. So the first one that we're going to use is called autoPatch. So dun, 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 dun. Okay, it's reconstructing. Okay, my 3 steps. I have my final mesh, step 3. So as you go phone info autoPatch can give you some info, sometimes it gives you, sometimes it doesn't give you. Well, device external faces into patches based on user supply feature angle. We know what is this feature angle. We have seen that a lot. Also, you have auto patch. It works in the same way as in Surface AutoPatch, if I will recall. You have the held option, and here I don't see minus parallel. It doesn't work in parallel. Okay, so but basically AutoPatch, and then you give an angle. So let me go AutoPatch. It will rig the latest time, by the way, and my angle. Let me give 150. And let's see what happens. So there. Okay, so it just found one patch, okay? It didn't do anything, and it created the new folder. So this is not okay. So now it's quite funny because this auto patch, if I would recall, will be the opposite of surface auto patch. Surface auto patch, you put a large, here you put a small, so it's the complement, but it's a little bit confusing. I don't know why the developers they haven't standardized that. But in any case, let me put auto patch 30. And there you go. 30, it found many, many faces. Maybe I'm not interested in all those faces, and see that automatically will add this name auto 0123. Then you will need to identify and change the name. So let me increase that angle. Let me use 60. Okay, probably this was too big. Okay, it's not ideal. Let me go 50. Okay, so one, two, three faces is not ideal, so should be 40. And now let me go 40. And there you go. One, two, three, four, five, six. Okay, that should be. I open here. And there you go. So I want to access the last one. So a little bit slower because it's a much finer mesh. Okay, so and here you go. So this is what we have, and each color represents a different patch. Okay, so it wasn't this one. Okay, we have some problems also. These are issues related to the mesh, but see that it's doing all the patching and probably capture here. It didn't capture very well, so that I can leave it as an exercise to use to see how to fix that issue. Okay, but pretty much this is how it works. Okay, so it will capture those patches with no problem. And actually, let me go a step back. And let me do something better. Okay, I need to check this one. Let me erase 4, 3, and 2. I just want the first step, which is the Cartesian, should be perfect. And in this step, I will apply this. Okay. Okay, so now I know what is the problem. Okay, so let me go here. Edit. Okay, yeah. That one is not going to work. It will identify all the chart angles. Okay, let me reconstruct part time 2. Okay. Okay, let me go for 40. Uh, 1, 2, 3. Okay, this one seems okay, seems better. So there was a problem in the last step in creating the boundary layer, and it was having no doubt those strange cells. Still here, probably there is something. No, here we don't have it anymore. BTK and ID, and this is what is happening. Patch 1, 2, and 3. Okay, and then you have a single for the pipe. But also, if you choose the right angle, it should find this division between the small and large pipe. Okay, so the previous one were having problems. The previous mesh was having problems in the final step. So you can fix that one to avoid no, it was capturing something else. So let me reduce the angle here. Ay, ay, ay. Two. And let's use a smaller angle. Let's use 20. Okay, 20 found the patches. Okay, so well, I didn't erase two, it doesn't matter. And this one, I want this one. You know, find this one. So this is one way to do it. Of course, if you have complicated geometries, this one probably is difficult to control, so it's better to do it using some graphical tool. It is up to you, but you have an option there. The other option, which I really, really like, the one that I'm going to show you the next, is using something that's called surface to patch. So how this works, as usual, minus help, some information, and also you have FOAM info surface to patch. Okay. Mm, mm, mm. And you can get some general info what it's doing. Okay. So basically it will read a surface STL OBJ, and using that information, it will try to patch your mesh. Okay. So it's a very nice concept, but similar problems that we were having here, that sometimes in the edges you have some collapsing cell. It won't work very well. But if you have a perfect mesh, I think you will get very good results. So let me go here, 4, 3. Let me reconstruct time 2. I want to reconstruct that one. So remember that here in this case, in geometry, we already have those patches. So I should have inlet, or not here, probably I should have a folder here, geometries. So in geometries, okay, actually, so yeah, you have it here, NE inlet 2, NE and inlet 1, NE is mixing elbow. So you have it there. So I'm going to use those individual surfaces to patch my mesh that we know is a single patch. Okay, so just to show you here, for instance, let me open this too. And these are the individual surfaces that we're going to use to patch our domain. Okay. So how we use it, surface to patch, and then the geometry. So it is NE, inlet 1, and there you go. So it will read the latest time and see that it's doing the patching. Okay. So now we should have the folder 3 with that information. So I patch, and just to be sure, okay, here, I don't have any patch. Then I move to the second one that I have now, the snap my mesh. I only have one surface there. And then when I move to the next step, I should have here, I have my patch. So by using that STL, you can create that, and you can imagine that also you can create you can use arbitrary surfaces to do the patching. However, be careful that sometimes this might happen, so this is a little bit precision. So see that is also including some cells from the neighbors there, so that might be a problem. So you need to control that as well. So you have an option to control the tolerance. Okay, so you go bam, bam, bam. Let me erase 3 surface to patch minus help, and you have here the tolerance. Okay, you have a default value that probably was too large, and let's try again with a smaller tolerance. So let me go minus tol, and it will be smaller, and let's see if this one gave better results. Okay, so this again, something iterative. You need to test it, try it, the tolerances. But I really like this technique. I use it a lot. In particular, now I do a lot of optimization, and you can get an idea. Optimization, patches, changes. So if I have my parametrical cat, I just get that from the cat. And actually, just in this case, now by reducing tolerance, it's perfect. Now you can do the same with the other patches. Not necessarily will be the same tolerance. So let's see. Let's try inlet 2 and inlet 2. Maybe there will be some errors. Who knows? So I start from 3. We patch everything. And let's see what we have. Ah, okay. I forgot to disable here. Go last one. And yeah, it did a very, very good work there. Okay, so patch that one, patch this one. Now let's patch outlet. So you get the idea. You do everything in the snapping step, and actually you can do it also in the castellation step. Okay, you can do that, but the tolerances are way much different, so you have to be careful there. Okay, so let me go outlet and let's see what we have in outlet. Since that had a phone. Okay, there. Um, Wonderbar, another perfect patch. Fantastic. So you have that one, and now let's do the final one, which will be the small pipe or the large pipe. So it's up to you. So let's go pipe small, and let's. So I don't expect good results in this one. Internal mesh is the one I want to see. This one. Here. Okay, it was another perfect match. Oh, fantastic. I wasn't expecting this. Okay, another perfect match there. And there you go. So another way to do, so this case probably it is easier to do autoPatch. Then if you have something more complicated, and if you have access to the cat also saved in the real surface, and you can apply that patching, fantastic. I really this technique, as I say, I really like this one. So now you can go. Let's do all with check mesh minus latest time. Okay. And to be 100% sure that you have all patches. Okay, so it's reporting you have this one. This don't care about this. It's a zero faces, so you can erase that. Usually I don't care about that. So there you go. You created your patches. So at this point that those patches exist, you can go and do a snappyHexMesh the boundary layer step. Be sure to do it in the latest time. And let's see what we have. Snappy, what we get. So let me run this one. So using the final one that you have all your patches, let's define the boundary layer meshing. Okay, so here it failed. Probably because I forgot to change now the BLX goal because you need to change the names, the naming convention that BL here. So recall here that those patches they have different names, so I don't recall how they are called. So you need to use the right name. So bam bam bam. So you have you have mixing elbow and pipe small. Uh, Pipe small mixing elbow. Yeah, it was okay. Sense. Okay, so let's go here. Three. Okay. And let's redo. Okay. I didn't check. So you have the all you can do the you can check in the Excel file. Yeah, probably yeah, this mesh is for surface refinement. So probably was a little bit yeah. I am in the limits here. So still I know that already when you go 1 to the 10 to the minus 4, you need to use another technique, no, the other techniques that we have seen. So probably this one is going to give problems. So as I was expecting, it's giving problems. Let me go and increase this one 0.7. Okay, and F7. And uh, probably, probably will work. Okay, so if it doesn't work, I will take the other measure that I will add on the mesh quality parameters, but probably will work. So see here, I already start to see that the determinant there is giving problems, it's iterating more. So yeah, the fact that it's iterating more, it is telling me that maybe will generate a not so good inflation layer. So let's wait a little bit. Okay, so there you go. It was suspecting it was trying to do something, but it didn't work. So we waste some time. Okay, let's take the this radical measure. So let me see if it works. So let me disable, put this one to 1. I will do just one iteration. I just want to grow some boundary layer and see what is happening. Okay, there you go. So be careful. Recall that what I do here is that I disable all the iterations. It's not doing any quality check, so it will grow the boundary layer. You are going to have your coverage, but if you do your sanity check with check mesh, it might not be the case that you have a very bad mesh, but I just want to visualize. Let's see. Actually, it wasn't that bad. Okay, I can live with this. But any case, let's see what we have, because probably we have the problems in the edge on the feature edges. So that's what I want to check. But any case, to do our purposes, we managed to create the patches. Okay, it's not here. So it's here. So we have the BTK, all the patches exist in our mesh. So bam, 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 bam. Okay, this is so there you go. All the patches exist, and the next step is the boundary layer. And here we have, you see that we have, okay, and okay, it worked. Huh? Okay, the original case doesn't work now. This one it works. And what happened here? I don't know where it. Okay, so it was something very small. There you go. You have the boundary layer there. Let me go. Bum, bum. You see there, it grows there. Probably here also will be something. yeah, you have something very small. So was probably here it is set to absolute size. It's not relative 0.7. Final layer 0.7. Okay, it is strange what is doing that. Somewhere I'm missing something. Probably an aspect ratio absence. Okay, the name of the patch is 3.5, but it's strange. But okay, we have here it worked fantastic. We have a mesh. Final technique to do the auto patch. As I say, this is the one I like. So yeah, I think for the moment, this is all I have to say for this mixing elbow, but probably in the future it will come back, and we'll do something else. So hope you are enjoying this training, and if you have suggestions for geometries and so on, just let me know, and if I have time, I can try to do something. So see you next video. Bye.